Hey everyone, it's Miss Bell here in the Science Lab, and today we're going to be talking about sound energy. You're able to hear my voice right now because when I'm talking, it's sending vibrations through the air and it's going into my computer, and my computer is recording my voice. And then when you are listening through your device and watching the video, that volume is turned up. The sound is coming from the speakers and going through the air and vibrations and going into your ears. And that's kind of how sound works. When we talk about sound, it's just anything that makes a noise and sends vibrations. Let's say a drum. Bang, 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 bang. And a dog. Ruff, ruff, ruff. Or maybe a siren on a police car or an ambulance. Wah, wah, wah. Those all make sounds. What about fireworks? In the sky, maybe around 4th of July if you've ever seen them. Or if you go listen to a marching band and you see all the instruments on the field, the flute, the trumpet, the trombone, the tuba. Those are all making sound energy. Have you ever thought about crickets? As small as they are, that it's a soft sound as far as volume goes, but they still make a sound. And what about a whistle? Yeah, I can't really whistle very well, but you get the point. Also, when you're in the bathroom and there's no paper towels, but there's a hair or a hand dryer on the wall, you push the button, the heat comes out, and you can hear that motor. You can hear that sound energy coming from that machine. What about if you're out playing baseball and the baseball is thrown by the pitcher, it makes contact with the bat, and the ball goes all the way out in the field? Well, that cracking sound where the ball meets the bat, that's sound energy. How about this? Oh, I hate when a balloon pops. Whether you squish it too hard, you sit on it, or someone pokes it with scissors or a needle, it's the worst sound. Some other sounds you can make with your body, or clapping, or doing this with your cheeks. It looks funny and feels funny and sounds funny, but it makes sound energy. What about this? I'm making sound with parts of my body. We can snap. Yeah, we can move our hands together really fast like that. It's all different types of sound that we can make. What about thunder? When it's outside in a big storm and you see lightning crack from the clouds, and then you wait to hear all of that thunder that's creating sound and vibrations going through the air all the way, no matter how far the distance, we can hear it in our ears. Science is so crazy sometimes. What about when you're outside in the fall and you step on a big pile of leaves, you hear that crunch? Or when you wake up in the morning and you eat cereal and then you hear that crunching, that sound is really amplified because the eating and the munching and crunching is happening in your mouth, which is so close to your ears, and those vibrations don't have that far to go, so it sounds so much louder inside your head when you're eating that cereal. But that's what sound is about.
In this experiment, we are going to be making rainbow bottles. And with our bottles, we're going to, in a sense, be making a musical instrument where we're going to be playing around with sound energy and different pitches and different volumes. As we fill our bottles with liquid water, If the bottle has no liquid or a very small amount of liquid, that just means that it's going to create a low frequency when we either blow or tap on the bottle, which also means it has a low pitch, like this. And the more water that's inside the bottle, it's going to have a higher frequency or a higher pitch, like this. Those pitches are going to create different types of vibrations or sound wavelengths as they travel through the air. The lower pitch vibrations are going to be low and slow and really spread out, versus the high pitch is going to be really tall and very close together.
So with this experiment about pitch, we are going to be working with rainbow bottles. For this experiment, you're going to need bottles, either plastic or glass. You're going to need some water. You're going to need food coloring, red, blue, yellow, green, and you're going to need some sort of tool to be banging on the bottles. I have plastic and a metal spoon, but you can use a rubber spatula or a wooden stick and kind of play around to see if those banging tools make different sounds. Right now I have 7 bottles. That's just because what I had. You can work with less, you can work with more. If you have more, you can make more sounds, and if you have less bottles, you can make less sounds. So all we're going to do is fill up the bottles, starting with one empty. So fill up with water, and the levels of water are going to get higher and higher and higher and higher, and we're going to see how that adjusts the sound or the pitch of our bottles. After we get the levels of our water, we're going to blow in them and hear the sounds and make sure that they sound correct. Then at the very end, I'm going to be adding my food coloring so that it looks like a rainbow. I'll start with my clear, then I'll go red, orange, yellow, green, blue, and purple. And then we'll have our rainbow bottles, and we get to have fun with science, bang around, blow in the bottles, and listen to the pitch. So with our rainbow bottles that I've made, we start with an empty bottle, and because there's no liquid in there, when I blow in it, it has a very low pitch, a low sound, which also means it has a low frequency. Those sound waves that are happening with the vibrations inside the bottle, they're low and slow. However, if I go all the way up to my purple bottle, which has the most liquid and the least amount of space for those vibrations to move around in, Listen here. That sound is higher. There's a high pitch, which means a high frequency. So the sound waves go like this. Very high, very fast. There's more waves put together in a space. So low pitch, high pitch, low sound, high sound, low frequency, high frequency. Now, that doesn't mean the volume. The volume comes from how much or how little I'm blowing into the bottle. This is a low volume. I'm barely blowing anything, and this is a high volume. I'm using more effort to blow air into the bottle, so that adjusts the volume. A low, soft volume versus a loud volume. Now what happens if I use my different hitting tools? I'll try my metal spoon first. You can see as I start here and I go all the way up to the purple, that pitch starts low and gets higher and higher and higher and higher and higher and higher. Now let's try with my plastic spoon. Again, you can try this with a rubber spatula. You could even try it with different items around your house, a stick, a CD, and you can play around with the sounds. Or you can try to figure out the notes to certain songs like this. Can you name this tune?